Welcome to AUT-140 Station number 5, which is brake service. So the learning tasks for this station are going to be 1. Understanding and explaining brake system components, 2. Performing a full brake inspection, and 3. Performing a simple brake service on a vehicle. Let's kick off onto safety. So 1, we are working with heavy parts, performing tasks that require lifting, bending, stretching, and other types of physical activity. If you require assistance with any of these tasks, please locate lab staff and ask for assistance as needed. 2, when working on or under a vehicle, it is imperative to stay aware of your surroundings at all times. Many parts of the car and other equipment have the potential to cause injury if you're not paying attention. And 3, if you're not sure where something goes or are unsure how to use a piece of equipment, then stop, get attention of the lab staff, and have them assist you. Far better to take it slow than damage equipment or injure yourself. So to start, what is a brake service? So a brake service consists of a comprehensive brake system inspection, followed by corrective action and maintenance procedures. Typically, a full brake service will involve replacing the brake pads and shoes, replacing and lubricating the hardware, resurfacing or replacing the rotors and drums, and making any adjustments necessary to ensure optimal braking performance. In the case of this lab, we're going to have you do a full inspection, and then I'm going to have you replace the pads on the rear of the vehicle. So we're not doing a 100% brake service. You're not going to be cutting the rotors. You're not going to be doing any of that, but you will remove the rotors and pads on the back and reinstall them after you've done the inspection. So that raises the question, what are we inspecting? So brake inspection is going to break down into 4 major areas. 1, inspecting the hoses and cables. 2, measuring brake pad thickness. 3, measuring brake rotor thickness. And 4, measuring brake rotor runout. Which leads to the question, why are we inspecting these things? 1, leaking hoses and calipers can cause complete loss of braking on a vehicle, so this is very important to catch quickly. 2, brake pads that are too thin will create a large amount of noise and reduce braking ability. Again, bothersome to the customer and very dangerous. 3, rotors that are too thin will reduce the braking ability of the vehicle. And 4, rotors with too much runout or wobble will cause the car to shake whenever the brakes are applied, so we need to check for that too. So let me give you a quick overview of what we're inspecting before we actually go out on the car and do it ourselves. Let's start with inspecting the hoses and cables. So when inspecting the brake hoses, what we're looking for are cracks, tears, or leaks in the line. I have a fluid leak here, and you can see the wetness on the hose. That's almost always your telltale sign for any type of brake fluid leak, because it's going to be wet and dirt's going to accumulate around where the leak is at. So checking brake calipers and pads. We're going to check the caliper for any missing hardware or fluid leaks around the pistons and any looseness in the caliper when it's mounted. These are the brake pistons right here. When we actually pull the caliper off the vehicle, we're going to look at these boots to see if they're leaking, torn, cracked, etc. To check the pad thickness, we're going to use thickness gauges where we'll measure the thickness of the pads on the vehicle. So we're going to have these special little thickness gauges that we're just going to hold up to the pads to see if they're within specification. So checking the rotors, visual inspection. Rotors with excessive gouging or surface damage do not provide a good surface of the brake pads and can severely reduce the braking ability. So generally speaking, what we're looking for is to see if the rotor is smooth and doesn't have any deep cuts or any cracks anywhere on the rotor. First thing you're going to do is be able to spot it, just like we have on the right side, these deep cuts and glazing here on the rotor versus something new on the left where it's pretty smooth and all fancy, fun, and free. Also keep in mind that when you are visually inspecting the rotors or working on the rotors, do not touch them with your bare hands. If you get dirt or grease onto the surface of these rotors, that grease is going to go into the brake pads and ruin them. So be very careful not to touch the front or the backs of the brake rotors when you're working with them. Next is going to be checking rotor thickness. So brake rotors are made of cast iron, and this heavy metal is helping to dissipate the heat that builds up during vehicle braking. Once they get below specification, too thin, they cannot properly handle the heat load from the braking system and they can warp or crack. We have the Z06 Corvette down here racing around the track, and you see that it glows red hot. This is why it's important to make sure that the brake rotors have proper thickness, because that thickness is giving more meat, more mass for that heat to dissipate. If they get too thin, they're not going to properly get rid of the heat. The braking system is going to work like garbage. To check the rotor thickness, we use a micrometer or a brake vernier caliper, and we measure the thickness of the rotor at various points. Then we compare it to specification to know if it's too thin. Brake rotors don't always wear evenly, so in measuring thickness, we must measure in at least 8 different spots to make sure we don't have any high or low spots on the rotor. If you look at the warping here on the right side, you see that when we measure in different spots, we can spot some of this warpage as long as we're getting enough measurements. If you don't measure at least in 8 spots, you're not going to catch this warpage, and you're going to think that the rotor's fine. Next is going to be checking runout. So brake rotors can also wear in a way that makes them wobble side to side, which is known as lateral runout, or we simply call it brake rotor runout. This is measured using a dial indicator, which will show the side-to-side wobble of the rotor as it turns. Alrighty, with some of the basic theory down, we're going to jump right into the hands-on. But first, we need to look up specifications for our 2019 F-150's braking system. And what we're going to be looking for specifically is brake rotor thickness. So we need to know what the minimum thickness is on the brake rotors of the F-150 so we know whether they're in spec or out, thus letting us know whether those rotors can be machined or they need to be discarded. So we're going to look up that spec and then we'll jump right into the inspection. Okie dokie, so to look up specifications, we're going to use our service information software known as ProDemand, and you should have a little hot link on the desktop of your laptop that you can double click and it should bring up the ProDemand website. If not, you're going to have to open your web browser, either Firefox, Chrome, or Internet Explorer, and you're going to have to go to www.prodemand.com. Once you're there, you're going to go ahead and click the login button and it should auto log you into the system. If it doesn't, come see lab staff and we'll go ahead and get you a login. Once you're at the main page, you're going to go ahead and click select vehicle and we're going to go to vehicle selection. So I did tell you this is a 2019 F-150, which it is, but sometimes ProDemand doesn't update as fast as we want it to. So we're going to use a 2018 F-150, which does have all the updated information. And it's the same vehicle, same chassis, nothing changed between 2018 and 2019, but our software simply isn't updated yet. So you're going to select 2018, you're going to go down to Ford, and then we're going to go to F-150. From here, we're going to choose the 2.7 liter engine, which is what it has, and ours is an XL model. Once there, we're going to select pickup because it's a regular cab pickup. Ours is a rear-wheel drive, not a four-wheel drive. And then the transmission should auto-select for you, at which point you're going to click Use this vehicle. Now, it's going to bring up this jump page here, and we have a search box at the top, and since we're looking for brake rotor specification, all we have to type in is brake rotor. It's going to give us a top search, brake rotor. We click on it, and then it's going to give us a bunch of icons. Top repairs for brake rotors, causes and fixes, specifications, OEM testing, etc. There's a whole wealth of knowledge to be had in ProDemand, which we will cover in other classes in deeper detail. But for now, know that when you type in something in the search box, such as brake rotor, if we're looking for specification, we're just going to click on specification. It'll bring you to the jump page where it shows you exactly what we're looking for. Front disc minimum thickness, rear brake disc minimum thickness with vehicles with electronic parking brake, and then rear brake disc minimum thickness with vehicles with mechanical parking brake. Spoilers, yours has an electronic parking brake, so this is the specification you're going to be using. I've blurred it out here on the screen so that you can't see it on my video, so you're going to have to go into ProDemand, find this specification, and then you're going to mark it down on your inspection sheet, which is inside your packet. Once you have that specification written down, you're good to go, and we'll move on. To get started, we're going to raise the vehicle up to about waist height. You can raise it higher if you want to. The big takeaway is make sure that you bring it down and rest it on the locks before you work. Shake it a little bit, make sure it's good. From that point, we're going to remove all 4 tires on the vehicle. So you're going to take your impact gun, hook it up to the airline, make sure that you have it on loosen, not tighten. Take your impact socket, make sure the impact socket is secure on the lug nuts, and remove all the lug nuts on all 4 tires. I'm just going to show you 2 because it takes a certain period of time, but I take the lug nuts off, I set them aside where I can find them, don't put them on the ground where you'll trip. Once you got all the lug nuts off, just go ahead and take the tires off, move them out of the way so you don't trip on them, you'll be fine. Next up is going to be removing the front caliper so that way we can get to the rotor itself for a measurement. Righty-tighty, lefty-loosey is going to get these bolts off. There's only 2, so go ahead and loosen them up, take them out, and once you have the bolts out, you're going to start rocking the caliper back and forth. So rock it back and forth, pull it out, and then once it's off, we're going to take a little bungee cord here and we're going to attach it to the caliper itself, and then as you can see here, I'm going to hook it to the coil spring. So in my case, I'm going to attach it to the coil spring right there, and that's going to stop it from hanging. You don't want to leave the caliper hanging by the brake hose, otherwise it's going to put too much force on it and you might damage it. So make sure that when you hang the calipers, you're hanging them out of the way and there's no tension on that brake line. With the caliper out of the way, we're going to remove the brake pads, and keep in mind you do not want to touch the brake pad material with your fingers. You need to touch the backing plate or the sides. Do not touch the face of the brake pads. You will contaminate them. So as you pull them off, make sure that you're grabbing and pulling on them without touching the brake pad material at all. Also, with the pads off, make sure you check the hardware. There should be no dirt or debris or rust right here on this hardware. Next up, we're going to measure rotor thickness, and we're going to have to use our brake rotor caliper. So this device measures in thousandths of an inch or millimeters, depending on which setting we choose, which can be changed with the button here. And all we need to do is turn it on, close the jaws, and zero it out. And that's going to give us a starting point for measuring how thick these rotors are. So as we slide it back and forth, the gauge should change. So what we're going to do is head over to the rotor. We're going to open up the jaws and then tighten it around. Make sure the flat part of your caliper sits against the rotor nice and flat, and then the pointed part digs into the other side. Use a little wheel right there to tighten it down. And then all we're going to do is read what we get on the gauge, which is 1.352 of an inch. So 1 inch and 352 thousandths of an inch. This is my first measurement for rotor thickness. So what you're going to do is you're going to write this down on a piece of paper, like a scratch piece of paper, because you're going to make 7 more measurements, and we're going to need to compare all 8 measurements against each other. So if this is your first one, write it down. I have 1.352. Yours might be slightly different. That's okay. Please be aware that your measurements are going to be a little bit off because this is a manual measuring piece of equipment. So your hands are going to cause imperfections. So your measurements will not always be exact. This is not an exact science. So you might get 1.354 or 1.3.0. It does not matter. That's okay. We're dealing with a little bit of imperfection here, so don't sweat it too much. Because as you can see, even in my video, it fluctuates between 1.352 and 1.353. So you're going to have a little bit of imperfection. That's okay. At this point, you're going to turn the rotor 45 degrees and make another measurement, because like I said, we need to make 8 of them. So this will be your second of 8 measurement. Same thing, make sure it sits nice and flat on one side. Don't tighten it down too much, and record. So as you can see from my second measurement, I get 1.349, which is 0.003 or 3 thousandths of an inch thinner than the first measurement I had. So right now, I have a difference of 0.003 of an inch, 3 thousandths of an inch between my first measurement and my second measurement. That means that this part of the rotor is thinner than the first part that I measured. This is important to keep in mind because, one, we find parallelism, what I mentioned earlier, where we get that kind of wave inside the rotor. This is 3 thousandths of an inch of parallelism. Also, this is going to be a lower part of the rotor, so if we were going to record what rotor thickness was, I wouldn't use my first measurement, 1.352. I would use this one, 1.349. You always go with the lowest measurement when you record rotor thickness on your sheet. At this point, you're just going to turn the rotor 45 degrees and make all 8 measurements. Again, be careful. Don't rush it. Realize that your hands are going to be unsteady, so you need to be careful, but make those 8 measurements, and you're going to write those down after you have done a full 360-degree tour of that rotor. With all 8 measurements down, you can find rotor thickness and parallelism. 1, rotor thickness is going to be the lowest measure of all 8 points. So whichever one is the lowest number is what you're going to write down on your sheet for rotor thickness. Again, that's the thinnest point. That's the part we care most about. 2, finding parallelism just involves taking the largest number out of all 8 measurements and subtracting it from the smallest number. So take the biggest measurement you have, the smallest measurement you have, subtract them from each other, and that's where you're going to get your parallelism from. You're going to go ahead and record that parallelism on your paperwork, and please note that there is no spec in ProDemand for this vehicle on parallelism. However, manufacturers generally set that at 0.002. So if you have more than 2 thousandths of an inch of parallelism, there is a noticeable amount of warpage in that rotor, and it does need to be machined. Next, we're going to measure rotor runout, which is a direct measurement of that side-to-side wobble we talked about using a dial indicator. But first, we need to secure the rotor into place to make sure it doesn't move unintentionally. We're going to use the lug nuts installed 180 degrees apart from each other, run them down by hand as tight as they'll go. Then once you do, you're going to flick or zip it once or twice with the impact to make sure they stay in place. Zip, zip, that's all it takes. From there, we're going to set up our dial indicator, which is this device here. The dial indicator measures movement as it pushes on the bottom of the pintle, as you see here, in thousandths of an inch. It also has an adjustable gauge face on it, so we can rotate it and zero it out when we need to. So first things first, we got to install the dial indicator into its adapter, and we have an attachment end here to my left, and all it involves is loosening this tie-down screw, installing the dial indicator all the way to its base, and then tightening that screw down. Do not need to tighten the screw down very tight. As long as it holds in place, you'll be okay, because you're going to need to loosen it at some point and articulate it, so not too tight. From here, we're going to mount up the adapter to something that doesn't move or shake with the rotation of the rotor, so I'm choosing the tie rod end here. So I'm going to take my vice clamp and squeeze it down, and as you can see in the video, it's a little too loose, so I just tighten it up a little bit of a turn. It should bite in there, and it should stay nice and steady. From here, I need to get the pintle or the point of the dial indicator to press against the rotor. So I loosen the lock nut that I tightened earlier so that I can articulate it, and I push it up against it. Once I get it where I want it, I lock it down, and now I need to put tension into the adapter snake, so I turn this knob here, and it should stay tight. However, it's still a little bit loose. I keep turning the adjuster knob for the little snake adapter, but it's just not putting enough tension to hold the dial indicator in place in a steady fashion, and I let go to see, and it just wobbles too much. So I take the tension out, and I turn this lock tab righty-tighty, and this is going to put a little more tension into that adapter snake. Once I have that, I set my dial indicator up again, making sure the pintle sits nice and flat, and then I turn it. And I turn, and it feels pretty good right now. So I think it's pretty solid. The last thing I need to do is I need to make sure that I tighten that lock nut down, and that should hold everything in place just like that. Beautiful. I have enough tension right there on the pintle so it's not moving, and then I'm going to rotate my gauge face so I can zero it out. Notice how touching it is going to cause it to move. It's that finicky. But once it's set up, I'm going to take my rotor and turn it 360 degrees. I'm going to watch how much that needle moves on the face of the dial indicator. It should move very little. Let me zoom in a little bit closer with a better camera here. And again, we watch and we want to see how many marks that needle moves across. So we're just turning it, very little movement, great sign. Please be aware that each one of these marks is 1/1000th of an inch, so 0.001. Having watched this turn over and over again, I realize that I have almost no run out at all. I barely move this needle while it's turning, so I have less than 1/1000th of an inch of run out on this rotor. Please be aware that the average spec for rotor run out is 0.02 of an inch, or 0.002. If you have your dial indicator set up and you start getting more than 0.100 of an inch of run out, like it just keeps wobbling all over the place, 9 times out of 10, that means you have the dial indicator set up incorrectly. So make sure you're double and triple checking your mounting if you're getting more than 0.100 of an inch of run out. If you can't get the dial indicator set up correctly, come see us and we will help you. Once you've measured and recorded rotor run out, you're going to dismount your measuring hardware. Pretty simple process, the opposite of installing it. Please be aware that your vice grips may be a bit tight, so they take a little bit of muscle. Make sure you loosen the tension on the snake adapter, and then all you're going to do is pull the dial indicator apart from the way that you got it. Don't leave it mounted inside of there. It has a tendency to damage and break. Just loosen it up, don't lose any of the hardware, and then we'll move on to the next measurement. Next up is measuring pad thickness, which we're going to use with our pad thickness gauges. These are broken down into millimeters. All you're going to do is find the gauge that matches the thickness of the brake pad that you're measuring, and that's what you're going to write down on your spec sheet. Again, make sure you're not touching the brake pad material with your fingers. Make sure it stays nice and clean while you're measuring. Alrighty, so at this point on your inspection sheet, you should have specifications for front rotor thickness and rear rotor thickness, and you should also have the measurements for pad thickness, rotor runout, and rotor parallelism for at least one side of the car. With all our measurements made, we're going to button up the calipers and get everything back into place. So first things first, we got to get the brake pads back in. Make sure you line the brake pads up correctly with the rotor. You can put them in backwards. It's hard to miss, but it is possible. Make sure you line it up with the rotor, and there's going to be tangs on the bottom of the brake pads that line up with the hardware. So line the tangs up, and all it does is slide and press into place. Again, don't touch the surface of the brake pads, and don't touch the front of the rotors while you're putting this on. Don't get the rotor dirty. Back pad is just like the front. Make sure you line up the tabs, and it should slot into place. This shouldn't be too difficult. The brake pad's in place. Next comes the caliper. Simple enough. We're just going to disconnect it from the cord that's holding it, and it slides into place. Please keep in mind that these guide pins at the top and the bottom do move. You might need to press them in so that you can get the caliper on. Don't go hammering on the caliper if the guide pins are in the way. Make sure they're out of the way first. So there you go. It's going to walk around a little bit on the brake pads, which is okay. We need it to move a little bit. All you're going to do is move it until you can get the bolts to line up with those guide pins, and then you're going to thread them in by hand. Keep in mind that this is tricky and it's easy to cross thread these bolts. If the bolts don't line up with the hole, you need to move and knock on the caliper a little bit. It's going to have some free play in it, and that's good. Just make sure that you move it around until you feel those bolts grab onto the threads of the guide pin, and then just tighten them down on in there by hand. Don't use tools until it threads all the way in by hand to avoid cross-threading them. With that all done, make sure the bungee cord comes out the coil spring, set it aside, and we'll move on to torquing. So setting up the 3/8 torque wrench is pretty simple. Hit the power button and turn it on, and we're going to cycle it to foot-pounds because we're going to set it to 10 foot-pounds. So you're going to keep pressing the FN button until it changes to foot-pounds, and then scroll all the way down or up until you get to 10 foot-pounds. That's going to be our torque spec for these bolts on the caliper. Once it's set, you're going to righty-tighty it. Make sure you have it set in the right position. You're going to take your appropriate socket, walk on over to those caliper bolts, and using the handle end, you're going to turn very slowly. You're going to have to ratchet it down a little bit, but once it gets a little snug, you're going to turn until you hear a beep and you see a light. You should be able to see the light on the back of my hand. It goes green and you'll hear it beep. That means you're at the proper torque. Don't rush this. Go slow and apply torque smoothly. That's how we need to do this properly. Same thing for the bottom one, where we'll actually be able to see it if I get down here. And I'm going to hold it from the handle all the way at the end, go down slowly, 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 and then it beeps, turns green, bam, there it is. That's simple. Go ahead and set the torque wrench aside. It will turn itself off all by itself. At this point, you're going to get the lug nuts off that we used to hold it in place, put the tire back on, and then you're going to reinstall the lug nuts for this tire by hand. So do it by hand. You can use the socket if you want to. Do not use the impact wrench. Only install these by hand the way that I am. No impact wrench. Once you've got that, you're going to go to the other side and do exactly what I just taught you on the other side of the car to make those measurements. Just to repeat it again, you need to be making the same measurements on the other side. So you're going to have to pull the caliper off. You're going to have to make those 8-point measurements. You're going to have to hook up your dial indicator to get that run out. You're doing exactly what we just taught you. You're just going to mirror it on the other side. Once you finish with that, then we're going to move on to the rear brakes. So the rear calipers are pretty much a mini version of the front, with the difference being they have an electronic parking brake on the back, which is this device right there. So make sure that when you're working on it, you don't break that tang off of the connector. But otherwise, it's pretty much the same. We just need to use a wrench on these hold-down bolts right here. So you're going to use your wrench and then a ratchet. So you're going to need the wrench to hold the nut in place, and then you're going to use the ratchet to get the bolt off. So holding the wrench, you're going to righty-tighty, lefty-loosey that bolt right on out of there. Just go ahead and loosen it up. Again, make sure you don't snap any electrical connectors. Be delicate with the parking brake so that you don't damage it. I set my bolt aside, and we're going to speed it up here a little bit. We do exactly the same. Use the wrench, use the ratchet, hold it in place, break the bolt loose. Once you've gotten it taken apart, set it aside. Then we're just going to wiggle the caliper off, and once we have it off, we're going to place it on the rear axle. No need for a bungee cord on this one. It'll stay perfectly in place right there. Then you're going to take your brake pads off like before. Again, don't touch the face of the rotor, don't touch the face of the pads. Measuring the rear rotors is just like measuring the front. We use the same tool and everything. We're going to make those 8 points of contact. We're going to find those high points. We're going to find those low points. And then we're going to do the math once more to figure out what the parallelism is and what the actual thinness of the rotor is to see if it's within spec. So make sure you make those 8 points of measurements on your scrap piece of paper, make the calculations and write it down. Afterwards, of course, comes measuring the brake pads themselves. Measuring these is the same as the front. Set them on the bench. Make sure you use your thickness gauges. Find the gauge that fits, note its thickness, and then you're going to write these specifications down on your brake inspection sheet. Speaking of inspection sheets, I want to make a note that you will not be measuring runout on the rear brakes. If your inspection sheet has a spot to measure runout on the rear brakes, just write N\A, which means non-applicable, because I'm not going to have you measure it. It's way too much of a pain, and honestly, in the real world, we don't typically measure runout on the rear brakes unless there's a serious problem. Reinstalling the rear brakes is pretty straightforward, much as it is on the front. We get the brake pads back in. Again, there are guide plates. You can put them in backwards, but it is difficult. Make sure you line the tangs up and slide in. It's pretty intuitive. Same for the front. Same for the back. Don't put them in backwards. It's going to be a bad time. Once you have that, we're going to slide the caliper back on. Guide pins work on the rear just as they do on the front. Make sure they're out of the way as you try to slide the caliper on. Don't break the rear parking brake. Get the bolts in there, finger tight again. You're going to have to wiggle jiggle the caliper until they get there. Make sure you don't cross thread these. Be careful. No tools, only by hand. Only by hand. Don't cross thread or it's going to be a bad time. Once you get that, we're going to use the torque wrench again, 10 foot-pounds, same as the front. Turn it, tighten it, make sure that you get the beep when it's at 10 foot-pounds. Look for the light, listen for the sound. Do the same for the top bolts as you do for the bottom. Once you get those torqued on, you're going to reinstall the wheel, mount the wheel up. Again, only by hand. Don't use the impact wrench to get these lug nuts on. Just as we did with the fronts, we're going to do with the rears. You're going to make all the same measurements minus the run out for the other side of the rear brakes. So you're just going to follow the same procedure. It's exactly the same for the other side. Get all those measurements so that you have all the measurements for the rear brakes just like you did for the front. Once you have all the measurements for the front and rear of the vehicle, you're going to fill them out on your inspection sheet along with the other questions that are on the inspection sheet, and then you're going to get lab staff and you're going to show us. And as long as you filled it out correctly and everything looks good, we'll give you your signature for sign off on the brake inspection sheet, and then we'll move on, button up the wheels, and get you your last signature. As promised, last but not least, we're going to torque down the wheels. You're going to set the torque wrench to 50 foot-pounds. It is set the same way we did for the 3/8 one, so make sure you're on foot-pounds. Set it all the way to 50 foot-pounds, and then we're going to torque the wheels down. As we have covered in previous stations, and we'll go over here again, you need to make sure that you're torquing in a star or a crisscross pattern. So whichever bolt you torque down, you're just going to torque the one opposite to where it's at. That's what we mean by a crisscross pattern. This is going to make sure that the bolts tighten down correctly and the wheels go on correct as well. Again, pull down until you hear it beep. So you're going to see the light go off green. You're going to hear it beep. Don't monkey wrench this down. Be delicate about it. Torque needs to be applied smoothly. So you're just going to crisscross it till they torque and you're all good. You're going to do this to all 4 wheels. Make sure all the wheels are properly torqued, and then you'll be set and good to go. And once you get all the wheels torqued down, you're going to go ahead and get your final signature for the wheels installed and torqued. And this will cover you for the brake inspection lab. Normally we do a summary here, but we're not going to cover it this time because there's just not that much here. As we wind down this lab, I just want to let you know that this is done once in practice only, so there is no hands-on test. You still have homework, you still have a written exam, but there is no hands-on test. So make sure you handle all the rest of the paperwork that needs to be done, and that'll finish you out for this lab. We'll see you at the next one.